Hey everyone, thanks so much for joining us. This is Desmond here from NextWaveSTEM. Just a heads up that we will begin in about 5 minutes. We are planning to start on time. So thanks for joining us. In the meantime, our same housekeeping notes as per usual. If you want to use the chat and just share who you are and where you're from and what you teach, we would love that. Thanks a bunch, and we will begin shortly. Thanks so much, everyone, for joining us. We're going to get started in 1 minute. Just a little lighthouse keeping for those of us who are just with us for the first time. We'd love for you to introduce yourself in the chat. If you've got any questions or comments about anything, go ahead and throw them in the chat. We've already gotten a really good question. We will be sending a copy of this webinar, the slide deck, and an actual video copy for everyone to have access to a little bit later on. While I'm here, I will also mention that my colleague, Sugandhi Chagani, she is our school partnership manager here at NextWaveSTEM. She's going to be moderating in the chat. So if you've got any questions and I don't see them, Sugandhi will catch them and shoot them my way, and we'll make sure to get them answered for you live on air. So I'm looking at my watch, and I actually, the current time is 2 o'clock. So we will go ahead and we will get started. Um, Thanks so much for each and every one of you who has joined us today. My name is Desmond Martin. I am program coordinator at NextWaveSTEM. And these are our weekly webinars. We're doing a spring webinar series in professional development in emerging technology. Today, our focus is 3D printing and 3D printing and design with a purpose. We are really excited because for the last over a month now, we've been interacting with educators, and we have a deep passion to connect with each one of you, not just because we want to support you as educators. Of course, that's what we want to do. But we also want to make sure that we are supporting our students as well. So today we're going to be talking a little bit more philosophically and showing some real examples of what it looks like to think deeply about what we print and why we print with our students. NextWaveSTEM, we at our core are an education company with technology as our passion. So for a little bit of background on myself, actually, we are, uh-oh, I just got word that the volume is really low. I'm hoping that's a little bit better. Can you guys let me know in the chat if you guys can hear me a little bit better now? Okay, very good. It sounds like we are looking okay. Good. Well, at NextWave STEM, we believe that students really need to get to a place where they're no longer just consumers of technology, but they're producers of technology. And the reason why that's really important is that our students are going to have to respond to some very challenging circumstances and situations, not only while they're currently students, but long into their adulthood as private citizens, as public officials, as scientists, as technologists, as bakers, cobblers, whatever profession the students are going to be pursuing. The world can change on them very quickly. And that's part of the reason why we're doing these webinars and why we have such a premier focus on emerging technology. So we also understand that while the world is moving very quickly, there's a kind of a divide when we think about how native we are in the world of emerging technology. We're focused on 3D printing today, and some of us on the webinar may have never done any kind of 3D design before, may have never run a 3D printer, let alone put your hands on one. We may have them in our schools and they're just sitting as paperweights. We want to let you know that it's a powerful technology that can be used for all kinds of different applications. I know you've heard that a million and one times before, but today we want to focus on what that could actually mean for you in the classroom and how we can take a very new, very limited resource with regards to knowledge and regards to skill level and transform that into something really powerful when it comes to your student learning. So with that being said, today we want to focus on 3 primary goals. And because we're focused on these particular goals, it is going to be a very interactive webinar from the perspective of, I'm going to ask a couple of questions, but you'll also see me using a lot of our software. Just got a couple of questions here and I want to pause. That's another thing I want to let you all know about as well. Any questions are great. When I see those questions, I'll make sure that I'll jump in and answer them live on air. One question that we got was, I want to buy a 3D printer. Will you share where we can get one at a reasonable cost? Absolutely. Someone already jumped in and answered that. Amazon is a place to go grab a printer. Definitely. Not all printers are created equal though, so we're definitely willing to have more of a conversation about that. And then the second question logistically was about the PD certification. PD credits are certified for Illinois with the Illinois State Board of Education. So if you are outside of Illinois, unfortunately, the certification will not apply to you. Sorry about that. But for our educators who are native to our native state, Illinois, that certification is for you. So back to our goals for today. We wanted to establish some real world design connections to objects that are actually printable by your students. And the reason why I say that word actually printable, oftentimes we say that anything that our students or anything that we as lifelong students think of is printable. Anything we can imagine we can print. That's only halfway true. There are physical limitations to what the printer is able to do, and the laws of gravity also will cause some issues with a 3D printer if we don't take that into consideration as we design. So we will take a look at what that means and how we can set up our prints to be printable. The second thing we want to do is get away from kind of the more STEMmy technical perspective of 3D printing and think about ways that we can use 3D printing outside of STEM fields. There's amazing opportunities in the liberal arts in what is traditionally considered social studies, what's traditionally considered soft sciences. We want to think about ways that our students are able to use 3D design and 3D printing in those applications as well. And then finally, we want to give you a resource dump, but not just pour a bunch of links and a bunch of sentences on your head. We want to talk about ways for you to get files, get printing, get support, take your printing to the next level. NextWaveSTEM is one of those resources, but we know that 3D printing, any emerging technology, is really dependent on a robust community of makers, tinkerers, people like me who might have a formal education in engineering, people like you who are really excited to learn more. Or if you are more advanced, we have Mark who does a computer integrated advanced manufacturing program. So he's running software and technology that has some crosstalk, and some of the same principles that are in 3D printing will also apply to the work that he does. We want to make sure that we can all talk and get those good resources. So at this point, we will press on because there's a lot to talk about and only so much time. So when we think about 3D printing, when we think about what 3D printing is, at its core, 3D printing is another form of object manufacturing. We are taking material and we're transforming that into an object. But before we transform material into an object, there are some fundamental questions that we should always be asking ourselves. And I would even go further, especially given the context of the Earth Day that we just celebrated, given the context of the global crises that we will inevitably face over time, we need to be thinking really concretely about what we physically interact with and the impacts that are going to have, that those interactions will have. And more than that, what we interact with, we have to think about what we make. Whether that is making a new chair, whether that's going to a steel mill and getting a new knife cut, whether that is inventing the next peripheral to connect to a computer, whether it's figuring out the next best light bulb. We have to think about how those things that we make will have an impact on many, many other stakeholders. So generally, whenever I speak with students, I always start with this idea, the fundamental questions. I ask them two hows, two whats, and then the big why. How does this object that I want to make my life better? Is it going to enrich my life at all? Is it going to be something that I'm proud came off the printer, or is it going to be something that came off the printer and is a throwaway? How does this object make others' lives better? This is a question that usually doesn't come up with our students, but every now and then they're very altruistic and they're thinking about something that family members can use or someone in their community can use. If it doesn't make my life better, assuming that it doesn't disappear, and we know that things just don't disappear. The laws of thermodynamics say that we can't create or destroy energy. That thing that we print came from someplace and it's going to go someplace. Can it be better in other people's lives? In the context of education, what does this object teach me? Is there something about the world that I didn't know before I made this object that I know now? Is there something about me? Is there something about my community? Is there something about my country or history or physics or fluid dynamics that I didn't know? And that this object, the production of this object now makes new information available to me. Um, and kind of in the same vein, what does this object help me learn? Something that I'm really excited to share with you today when we take a look at Tinkercad are objects in Tinkercad that are specifically designed to help our students put knowledge in context, and even create their own context for different forms of knowledge. Once upon a time, that idea of putting knowledge in context was best done by going on field trips or going on expedition to actually go see and experience knowledge where that knowledge resides. And then with some very, very unfortunate social and environmental impacts, people said, well, if I can't go to the knowledge, maybe I'll bring the knowledge to me. And that's how museums were invented. At this kind of context, now we're at a place where we can even go further and bring the object that might have just lived in the museum, if not the physical object, a facsimile, and make it real to us in front of ourselves. But I'm getting ahead of myself because I'm really excited. So we're going to talk about, what does this object help me learn? All of these questions dig into the really big overarching idea that everyone should have, and I really do mean this, everyone should be thinking to themselves when they're working with 3D printing and really any kind of manufacturing. Why do I want to make this object? Why? What's the purpose? Am I having fun? Am I killing time? Am I creating a problem? Do I have a reason to benefit people? Do I have a reason to hurt people? We should be more considerate about why we want to make the things that we make. And today we'll explore exactly what that means. So first and foremost, we want to print some things, and we want to encourage our students to print things that have real world connections. Imagining and kind of throwing some parts together that look cool, but don't hold any kind of meaning to the real world, or even significant meaning to the real world, it's not inherently bad. Imagination is great. It's where we get some of our best ideas and where we get ideas that have huge impacts on the real world. But we also want to empower our students to interact with the technology in ways that can have actual impacts on people. And there are some great examples. So at this point, I'm actually going to change our screen share because I want to talk about how Tinkercad, how our online tool for 3D printing and 3D design gives us some really important and really critical abilities to do that. So I'm going to switch my screen. And when you log into Tinkercad, if this is your first time with us or first time hearing about Tinkercad, Tinkercad is completely free. It is a part of the Autodesk suite. Autodesk is a design company that's been around for decades now, and they make computer-aided design software and accessories for things as easy as base design in Tinkercad that's cloud-based, integrates with Google Classroom, it's free for your students, probably for forever, up into Inventor, Diffusion 360, things that professionals use to make real products that you use every day. And this tool is really, really powerful. The first thing I want to talk about is the basic idea of how we make something in Tinkercad. And I'm not going to go super deep in depth with some of the things that we're doing today, but I want to get a general sense of our abilities. If you've been with us before, bear with us. You've seen a little bit of this, but we're going to go in a little bit deeper context. So in Tinkercad, the biggest difference between Tinkercad and what you would think of as a more traditional computer-aided design software is that Tinkercad does not really rely on your students' ability to draw. Is the easiest way to describe it. And usually in a computer-aided design software, you're going to grab a line or grab a curve. You're going to actually draw kind of like you would do in traditional drafting, except digitally, and then manipulate figures into 2 dimensions and 3 dimensions. Instead, Tinkercad assumes that you might not have the ability to draw and make everything match up the way that you want it to match up, and gives you predefined 3-dimensional figures. That's a really, really big benefit because that means that we're creating solid objects that we know are solid almost all the time. So when I grab that box and I drag it over into the work plane, and I'm going to zoom in on it, I know for a fact that this box has all its lines meeting. There are no holes, there's nothing askew, everything looks the way that it should. And that's going to be great for me because I want to print solid objects, all things considered, on my 3D printer, as opposed to objects that are hollow or have holes in them, depending on what I want to print. Now, many of these objects, the majority of these objects, the vast majority of these objects, we're able to grab and throw onto our work plane. I'm going to zoom in. And we can make modifications to these objects. So if I click on this little caret called the inspector, I get a menu. And the menu allows me to make some fine and minute details depending on the object. Right now, I've got this comb, and a comb is exactly that. Looks like this 3-dimensional shape, has a circle as a base, has 1 vertex, and is this solid where if I laid it on the side, it would roll around very awkwardly. I can take the top radius, kind of where this vertex of the comb is being shown, and actually change it. I can change it by grabbing that slider, or I can change it by manually entering numbers. So once again, I'm not going to get too deep into the weeds here, but Tinkercad gives us a lot of customization when it comes to physical objects. This is really important because the proof, the concept that I'm trying to get at is that even without the ability to draw, I can make this cone much, much rounder by adding segments, or I can create a very, very, very geometric representation of this cone by decreasing the number of segments. I'm able to make some extremely, extremely complicated shapes through the ability to use and subtract, add and subtract some more basic shapes. So you might be saying, okay, Desmond, that's all fine, great, and good. What does that mean? What are some examples of that? Well, the first thing I would say is, well, let's say that I wanted a box. And I wanted a box not to just be this random cube. I want this box to be something that's functional. And you're telling me that if I can add and subtract shapes, Desmond, we're able to make pretty much anything I want, right? And I would say yes. I'm gonna grab this box and pull it out long ways. And I'm gonna take another box. And this box, I'm actually gonna make a hole. I'm gonna make it negative space. So if I grab this box that's negative space, I'm gonna elevate it just a little bit. And then I'm going to expand how big it is also. Now, some of us who are a little bit clever can see that I've got a solid shape and then I've got a hollow shape inside the solid shape. Now, this doesn't mean anything right now, but if I take a negative, we're gonna do a little bit of math here. If I take a negative number and I add it to a positive number, what I'm actually doing is subtraction. This is design by subtraction. So I can take these two shapes, a solid shape, that's our positive shape, a hollow shape, that's our negative shape, and I can group them together. And when I group them together, now I've got a new third shape. That's my box. So this can get really, really complicated, really, really quick, but it's also extremely powerful. And it's not just boxes. It's pretty much any shape that you can work with in Tinkercad. You can do both additive and subtractive design to allow you to design pretty much any shape that you want. Really, really, really powerful stuff going on. So before we get too into the weeds and I see our eyes glazing over, the next thing that I want to talk about is actually our shape options. We know that we can take basic shapes and use them as solids, or we can use them as wholes, as negatives, and combine them together and get all kinds of different shapes. But Tinkercad doesn't want us to just be restricted to basic shapes as we design. So I'm going to scroll down a little bit. I'm going to highlight what we see here in our shapes menu. Tinkercad has basic shapes, text, and numbers, individual characters, connectors. They've done a few interesting partnerships. They've done a partnership with the Oregon Museum of Science and Industry to create a hangout space. We're going to see what that looks like and what our options are for design there. We're going to actually take a look at what are called shape generators. For those of us who have some experience writing JavaScript, you can actually write computer code that will generate your own shape in Tinkercad. We're not going to show you how because honestly we only have an hour, but that's something that you can do. Tinkercad allows us to learn how to make actual usable circuits. We'll take a quick look at that, and then we'll also take a look at what are called printables, objects that are designed to really show concepts of physical printing, and therefore you could think of them as kind of like blanks that are not designed to really be changed that much. The great thing about these objects though is that they're really cool and they have lots of powerful learning potential in them as well. So let's take a look at some of these. If I click on text and numbers, I can grab a text block, and I'm going to make sure that you can see that text block a little better. I can grab a text block and make that text say what I would like it to say, but I can also adjust how big or small it is. And just like I can do that with a block of text, I can do that with individual shapes as well. Individual characters, I should say, as well. The connectors are awesome because that's taking this to the next level when we think about a movable object. If you ever had a G.I. Joe, for those of us who played with action figures and or dolls, they are very, very similar experiences. If we play with dolls or action figures, we're used to this idea of having these joints that snap in and snap out of each other. And in Tinkercad, you can actually pull out and create objects that are jointed, that will be able to connect to other three-dimensional objects and serve as joints. So let's say I wanted to connect a square, and I'll actually do a quick rotation here. We'll flip this guy around. Let's say I wanted to connect a square and a cylinder. Well, in Tinkercad, just like before, by joining shapes together, in this case, just additive design, I've now created a pair of objects that if I printed them, this ball joint will snap right into the socket and they'll be opposable. We've now really empowered our students to create their own action figures or just to create any kind of objects that we want them to snap together. And that opens up a whole new level of learning. Oftentimes we think about our objects that are 3D printed as being solid, as being brittle, as being unable to move. And in actuality, when we're thinking about mechanical design, as long as we can design parts and understand the materials that they interact with each other, just according to the basic physical laws, there are some really, really powerful things that we can design. So those are connectors, and there are a bunch more of those connectors. For our students who might be stuck at home, shelter in place, or in more intense circumstances in quarantine, the Oregon Museum of Science and Industry, they had some interns a few years ago who worked hand in hand with Tinkercad to actually model their new space. And in modeling their new space, they actually had to design individual pieces of furniture that would go into their space. So if you're doing a design thinking project, or if you just want to encourage students like, hey, you've got some time, in addition to cleaning up your room, you might want to redesign your room. There are tools available for us to pull out designs. Let's see if my computer decides to cooperate. These tools that are available allow us to pull out designs and maybe design a whole new living room. Really depends on what we would like to see in the space. So that becomes a really, really interesting tool because we get to expand our world beyond abstract objects and think about things that may have been designed in the real world now being imported into Tinkercad. We'll get to that in a little bit as well. You can kind of think of this as a shortcut. In some situations, it may make all the sense in the world for our students to design a couch cushion because they want to do some product design and want a new couch cushion in their house or in their living room. In other situations, we don't want them to necessarily focus on that work, but maybe instead do the more planning with pieces already put together. Just got a good question from Lynn. Can you include windows and other objects that are already in the room? The answer to that is yes. And the way that we go about that is really thinking about the design for our home. So the OMSI pack that we've got here does not have, for lack of a better word, a whole house, like a whole house box space that we can drop in. But because we ourselves are clever designers, I can grab a basic shape like a box and just expand it and make it bigger. So let's say I have this box shape. And because I understand additive and subtractive design, I can also grab another box and expand how big it is Well, not too far. Expand how big this box is. And if I make this box a hole and join these two shapes, that could be the garage that Intel or Hewlett Packard or Apple was invented in, for all we know. We're able to generate larger areas that we can then come back and design within. So that's a workaround. In other design software, not Tinkercad in this case, you could import whole houses or whole boxes. Those are things that we could do. But there are also all kinds of workarounds that allow us to do some still really powerful design in Tinkercad. So what I'm going to do is I'm going to grab everything and delete so we can have a better sense of what's going on. Now, if let's say that you're doing a little bit more technical work and we've got students that have not only a good sense of angles, a good understanding of angles, are now experimenting with physics and geometry and trigonometry. Let's say we're working on the high school level. Well, Tinkercad has this really, really powerful advantage in shape generators. So in this case, I'm only going to focus on the featured. Shape generators are where the nitty gritty kind of taking me back to my engineering curricula comes in, and that we can do very, very fine adjustments to the actual object that's going to be produced. In this case, I can grab something called an extrusion. Just looks like a basic cylinder, and I'll zoom in on it and change our perspective just a little bit. So with the extrusion highlighted, what I can do is I can actually change the very contours of the shape itself. I can grab and expand out this way. I can grab and expand like that. I can adjust the pitch and angle. It's not freehand drawing at all, but you could create shapes with this extrusion. And then the idea of being able to adjust how much or how little of this shape becomes really, really powerful. And that's really where the power lies in the shape generators, is not in the shapes themselves, but in the way that we can adjust the shapes. So this very simple spring, imagine if you've got some technical acumen. I'm originally from Detroit. A rite of passage in Detroit for any young kid from the Motor City is that you've got to learn how to do something on your car. If it's changing your oil, if it's changing a flat tire, if it's changing an engine, pretty good chance if someone's from Detroit, they can teach you a little bit of basic handy car maintenance. I've learned through both informal and formal education about springs and spring rates. And if I wanted to model that, if I wanted to do some really technical modeling of this energy capturing device in a spring, I can actually add coils to the spring. Zoom out so we can see them. I can change how wide or how small they start. I can change the radius, both the internal and external radius of those springs, even to something that doesn't physically make sense. And of course, I can always adjust the size. So this tool that's already been built into Tinkercad becomes something that allows me to actually do some really, really powerful and robust product design. And there are so many other of these featured shape generators that allow me to do that. One of my favorites, I've had a couple of students kind of jump ahead of me before and jump into the adjustable box. If I just want to make a simple box and have that box be, oh, well, not that big, well, maybe that big. Maybe I'm storing trading cards. I can decide what type of box this is, whether the box is going to have a top drop in or a top slide on, and so forth and so on. The actual customization in this case is unlimited. And then finally, I want to talk about circuits and assemblies. So when I delete this box, for those of us who are working with programming Arduino and Arduino breadboards, we can actually grab components that we would see in a very common Arduino setup, say our basic breadboard, and I'll adjust so we can see it a little better. And batteries, and actual components. Some of these objects your students might have available to them right at home. Some of these objects you may have in abundance in your classroom. Tinkercad will allow you to really be positively engaged with your students as they are working through designing their next project. It really depends on what you'll have available to you. It really depends on what your students will have available to them. But Tinkercad becomes a powerful tool that lets them engage in 3 dimensions with the stuff that you might already have in your classroom. So that's kind of a really quick overview of some of the features and components and abilities that Tinkercad gives us with being able to design certain objects. And certain objects we can take shortcuts to designing as well. I'm going to flip back now to my actual PowerPoint presentation. So we talked about shapes and their ability to be edited. We often talked about, or also talked about addition and subtraction, ways that we're able to take in and take out these particular shapes. But we also want to think about ways that we can support the liberal arts and humanities learning with Tinkercad as well. Really, really powerful things. And there are a couple of different ways we can approach this. Some of them are baked natively into Tinkercad, and some of these other ways that we can go about this are external to Tinkercad, and I'll show those off as well. The first is this idea of artifact reproduction, kind of what we talked about before. We, in the annals of perpetuity, if we want to learn about Africa, if we wanted to learn about South America, if we wanted to learn about Australia, if I didn't live there, there was no Skype. There was no AOL Instant Messenger. I couldn't take a picture and send it to you via email. I needed to physically go to this place and make sketches and write diaries that might have gotten passed back to other people. And in the course of history, that means that travel is a big deal. Moving and taking objects from one place to another place is a big deal. But the 3D printer in 2020 allows us not to necessarily have to take a physical object, but to be able to produce an object that we can have access to and study in an interesting way. So let's flip back into Tinkercad and take a look at some of the robust options they have there for that. In Tinkercad, you might have noticed there is this section called printables. Printables are amazing because that's that artifact generation. Some of those artifacts more true to life than others, but also give us really, really robust learning potential. I'm going to clear my workspace just so we don't see any of that. I'm going to transition over to the printable section and click on skeleton. My students love probably way too much working with skeleton pieces in Tinkercad. That skeleton skull, becomes things that go on the top of different people's action figures and dolls and on the front of cars and on cell phone cases instead of pop sockets. This becomes kind of the go-to part for especially my young gentlemen who are in class. And you'll notice in the inspector, it says scaling is locked. What does that mean? That means that I actually cannot grab any of those dots to adjust its size. I can adjust its position. I can get this skull floating up in the air, for example, and I can adjust how far or up it's going to be. In this case, I'll drop it right to the workspace. But I can't make it bigger or smaller. And there is a particular reason for that. In the grand scheme of things, this is an object that shouldn't live by itself, but should live with all of these other objects as well. The different parts of the skeleton can be pulled out onto a work plane. Each and every one of them is scaling locked. And if you zoom in, especially on this chest section here, you'll notice that there are balls. And then on something like our skull, I'll rotate around, there's a socket. It snaps together as an actual figure of a human skeleton. And the really cool thing is that while I can do that with a human skeleton, that becomes, for some people, just a toy. For other people, a great way to teach anatomy. I just don't have to work with the skeleton, but I can also work with the dinosaur. So with the dinosaur, it's exactly what it sounds like, except a little bit bigger. And the only thing I'll show off, because we can spend all day with it, is this dinosaur skull itself. This is a really great way for our students to engage not only with the physical aspect of designing, but to also think about objects in their context. I may never, ever, ever get a chance to put my hands onto a fossil, but maybe I can create a fossil facsimile. And through some clever design, my dinosaur in this case, I can probably conjecture is a carnivore because these teeth look a little bit sharper than what I'd ever want to experience in life. Maybe through a little bit of clever design, I grab a box, and if I angle and shape my box correctly, and then turn my box into a hole and combine these two pieces, now I've modified my dinosaur skeleton, except I'm getting a little bit of an error mark right here. Oh, there we go. So I didn't get all the teeth, but my front teeth of my dinosaur, it appears now to be an herbivore in the front as opposed to a carnivore in the back. That's kind of off the top of my head, but a really, really good example. Oh, really good question from Steven. For the snap connectors, is there a preferred printing material? Example, PLA. Really good question. Something that we have to consider is what our actual 3D prints are physically made out of. PLA is the standard. As long as you don't make your connectors too small, PLA will work just fine. PLA actually does have a little bit of flex in it depending on the amount of infill and the way that your actual object is designed. So PLA will work. I wouldn't go anything too hard like PETG or ABS, but PLA, that's definitely a good way to go. So the last thing I want to show is this new printables by the Smithsonian. Just like Tinkercad partnered with the Oregon Museum of Science and Industry, they also partner with the Smithsonian Institution in Washington, DC, and use 3D scanners. And they actually 3D scanned objects in the collection. So if your students are here from Illinois and they want to get a sense of what Lincoln might have looked like, they can take the 3D design of Lincoln's life mask. We always see pictures, we see sculptures, but this is a great way for them to see, for example, what the face of Lincoln might have been. Or they might get hands-on with a representation of a real 3D scan of a fossil. It's one thing to use the approximation that we have in Tinkercad. It's a completely different thing to be able to see this model kind of laid out like you would see it at the Smithsonian. This is a really good example of taking the learning that we might see going on a field trip, something that our students may not have the ability to do right now, and bring it into their digital 3D worlds, but then expand on that and actually give them something that they can print. So I'm going to transition now back over to the slide deck. Artifact reproduction, really, really powerful thing that works in humanities. For our artists, 3D printing, 3D design is a great way to also engage our students. Fun fact, some of your students, their favorite Marvel movie is Black Panther. If their favorite Marvel movie is Black Panther, they see 3D printing all over it. The crown, the headpiece, that the Queen Mother wears is actually 3D printed. It's one of the largest 3D printed pieces that's been featured in major motion pictures. So tell them to look out for that the next time they watch Black Panther. So now we want to talk about, once again, ways for you to go even further. Everything that we've seen kind of lives exclusively inside of Tinkercad. But the great thing about 3D printing, 3D design is that it's an open community and it's an open source by and large community as well. So let's say your students are amazing designers. You might be an amazing designer, but there's something that you just can't find. You might say to yourself, can I actually go get a 3D printed object file and bring it in to Tinkercad to design more? The answer is yes. Tinkercad has a gallery. There are free galleries available. Thingiverse is associated with the MakerBot brand. Their gallery is free and open. My Mini Factory, Instructables, and many, many more. Desmond, what are you talking about? A free open gallery? Well, let's show it to you. If I go over to my handy dandy tab, kind of the cooking show style, I had something prepared for you in advance. Thingiverse, oh, as my tab has a load, Thingiverse is a place where people are designing and sharing their designs to be downloaded. And the amazing thing about Thingiverse is that it's just not odds and ends. Some people, Baby Yoda is our new favorite person. But we can actually find objects that become usable for us in the real world. There are people right now on Thingiverse printing for purpose. They are publishing their designs for masks and respirators for the COVID-19 crisis. We hear a lot about that every day. People are 3D printing. Well, those designs are open source. It's not really about monetizing. It's about creating something that's going to solve problems for the good. And files like this are all over the place. But let's say you have a 3D printer and you're having issues with parts for your 3D printer. Well, 3D printers, hobbyists don't like dealing with that problem at all. So if you've got a 3D printer, if you've got a machine that makes things, well, why not download and print the parts for your machine that might be broken? Or print the part that becomes useful for you and your processes. You can download a spool roller if your PLA, if your filament is actually getting in the way of your printer. These files are here. They're available for you to download at any time. But also in Tinkercad, if I go to the top level, your students sign in, they're not just going to be working automatically inside of Tinkercad in a design space. They have a dashboard and they have a layout to move through the entire website. And as a part of the way they move through that website is also this idea of a gallery. So maybe you don't want to go outside of Tinkercad. What you can do is grab a design that might be editable from the Tinkercad gallery as well. All kinds of designs made primarily by students of all skill levels who may or may not have imported designs or drawings. You'll find some really, really cool, really, really powerful things in Tinkercad as well. We'll just press forward because the time is running away from me. Time flies when you're having fun, as they say. Now, of course, you might be saying to yourself as well, okay, they're doing design. They've got some things they can look at digitally, but what if I want to get them an actual print? Well, baked right into Tinkercad, and there are some other services outside of Tinkercad available as well, is the ability to slice and 3D print objects and have them sent to either you or to your students. We'll do a quick screen share and show what that looks like. If I go back to my designs, I'll just click on my home screen. And let's say I really, really, really will love to get this fossil model sent to me. I can't get out the house. I didn't bring my 3D printer in with me from the office. I should have, but I don't have a 3D printer physically available to me. What's a great way for me to get my design? And I'll let this load up so that we can see our fossil. Awesome. I can hit this export. And when I hit export, usually we're downloading. We're downloading this STL and we're transferring it to our 3D printer from there. But this other tab that sometimes we don't play with very much is our 3D printing tab. These partners with Tinkercad, MakerBot, AstroPrint, Voodoo Manufacturing are places that we can actually send our 3D prints. In this case, I'll click on AstroPrint. They have a really, really wonderful online slicing platform. And what that will show is an example of the actual physical object that I've designed being made ready for 3D printing. We're not going to watch that load up just because we are running a little low on time. So I want to pause for a moment because we just hit you with a fire hose of information. There's all kinds of stuff everywhere. And don't worry, if you couldn't get it all, the recording, that's the word, the recording of this webinar is going to be sent to you, but also you're going to be getting the slide deck. So in the slide deck, things will be linked. You'll be able to click on things and navigate and check all kinds of things out. What's the purpose in doing this? Is keeping kids competitive in a changing job market. People are printing for great reasons when we think about mass or distancing devices, objects that will allow us to touch things like doors and our groceries without actually physically touching them with our hands. But we want to study Tinkercad and 3D design and 3D printing because we're building the critical 4 C's, those learning skills that you already know. But we're also developing life skills and really supporting what you're doing in the classroom when you think about meeting the NGSS standards. Mark asked a really good questions about CPDUs. Yes, there are credits available for today. You're going to get 1 hour as an Illinois educator, and you'll receive the credit hour email after the presentation today. So the next steps with 3D printing with your students. 3 things, and you're already doing one of them, so you're ahead of the curve. The first is that you want to expand upon your lessons. We've pointed you in the right direction with materials, but NextWaveSTEM, we have lessons and materials here to support you as well. In the follow-up email today, you're going to be receiving the link to register to access all of our curricula for free. 3D printing and a few other of our emerging technology curricula. Check them out, take a look, see what will work for you and your students. But at NextWaveSTEM, I know we got a question about obtaining a 3D printer. We can help you with that as well. You can go to Amazon and you can look for something on the lower end and you can look at the reviews. If you don't have a whole lot of experience with setting up and actually making sure your 3D printer is ready to go, it can be a little bit of a crapshoot and Amazon delivery is taking a while. We can point you in the right direction and get you a printer as well. And professional development. In times where we all could travel, you would be coming perhaps to our Chicago offices and doing professional development with us. For the near term and maybe longer term future, we'll also be doing our webinars offering PD credits as well. Secondly, and I've said this a couple times, so this is going to be good, the ISB clock hours are going to be sent after today's webinar as well. Oh, and big thanks to Segundi. Segundi has put our recommendations from all 3D Pre for our 3D printers as well. We can talk with you about the pros and cons of those printers on that list. And third, we would love for you to connect with us on social media. So this is our link for professional development on our website. Don't worry, you'll see that again in an email. That's our social media connection. We are on Twitter, we are on Instagram, we are on LinkedIn, we are on Facebook. We're not on TikTok yet, working on it. We might get there if we get through all the other things that we're going through. You'll also see on the slide my face in black and white and my email address. I'm talking to you with my face in color, so you get a full picture of who we are. And Segundi is here once again. If you want to connect with our school partnerships manager, she's here for us as well. I do actually, because Segundi has a special message for us. Segundi, I hope you're ready. I'm going to open up your microphone so that you can make our special announcement from NextWaveSTEM. So ready or not, here comes your mic.
I'm ready. Hi, everyone. Thank you, Desmond. This presentation was awesome. Once again, I learned a lot myself. And yeah, we are actually launching live online classes for kids very soon. I just threw up a link at the 2:51 Central time marker you'll see in the chat. So if you click on that, you'll see that we're opening up our classes. And we also have partnerships that we can form with schools if you want to bring that to your students. I'm going to throw that into the chat as well. We're really excited about this because we want to make sure that students have access to great STEM classes, and we know that it's been really hard right now probably for kids to really get what they need in terms of learning, so we're hoping that this can facilitate some of that too. Thanks, Des.
Thanks so much, Segundi. Really, really appreciate you coming on for that at the end. So I would love to just pause now. I usually don't do a very good job of not making it right until the end of the hour. I've given us 3 minutes, a whole 3 minutes. If you've got some questions about anything, about resources, about material, about 3D printers or slicers, I'm an open book. I might even have a good answer for you. Any question would be a good one. Segundi also just dropped the link for our school partnerships. So if you just want some more information, feel free to check in with her as well. We're giving some thank yous. We definitely appreciate you all. Well, if all hearts and minds are clear, as they say, then we are so glad that you're able to join us. We will be running this particular presentation with a few slight modifications this time next week. But we are also going to be doing our next webinar on next Tuesday at 2 o'clock, dealing with drones from home. If your students don't have drones, but are interested in simulating and learning more mathematical concepts through drones, we're going to take a look at some ways that we're able to do that. Thank you so much, everyone, for joining us. Be on the lookout in your emails by the end of the day for your ISB clock hours. And everyone, stay safe and have a wonderful day. Oh, before we go, can we print a drone? The short answer to that is we can print parts of a drone. That becomes a very, very interesting project. That's something we'll actually talk a little bit about in our webinar on Tuesday. So I hate to leave you with a to be continued, but to be continued. Thanks so much, everyone. Have a wonderful day. And we are going to be speaking with you soon. Bye now.